Hey guys, this is Curtis. In my last video, I shared that I was kind of disappointed in the GitHub Copilot at where it is today, and I didn't think it lived up to the hype. But had I not seen such impressive demos, I would have been blown away. I would have been like, "This is impossible." But I already was aware of what the the OpenAI type of technologies could do. I've been following closely, and to be honest, if I had not seen all that stuff, had not been following that, I would have been thinking this was like science fiction stuff. So I truly believe that technologies like machine learning based technologies like the GitHub Copilot are poised to change everything in our lives. And I wanted to just take a moment to explain why that's the case. First, a lot of technologies we use today are very legacy. They're legacy technologies. They've been improved in many iterations, but the base technology, uh, the origination of this technologies originated in the 70s and the 80s. For example, the first spreadsheet was produced in the late 70s. I think the name was VisiCalc by Harvard MBA, and for the Apple II. May get some of the details wrong, but you think about a spreadsheet. We think about, okay, spreadsheets are kind of modern things, and actually that was invented in the early 80s. Even the computers like the Commodore 64 had multiple spreadsheet programs. Obviously, that was a 1 megahertz machine, and then that introduced in the early 80s. And in 1982, we had that type of technology. And so, office programs, a lot of things we associate, yes, they've been improved by exponentially, but still these types of technologies existed. And today, there's a few things I think will drive this. It's driving machine learning to change everything. The first is that simply people are not smart enough to to solve the really tough problems we have today. So there's just a lot of back and forth about this fear mongering, so to speak, on machine learning, like um, about robots taking over and everything. But the reality is, or a lot of things we can't solve, like the protein folding. It's not stuff we can do. People can do. So the necessity is for these technologies. If we're going to solve these problems, they're going to probably be driven by machine learning and AI, because people are simply not smart enough to solve the world's toughest problems. toughest problems, world's toughest problems without assistance. It's how would we tackle these problems? There's only really 2 to 3 avenues. One is you use machine learning that's outside human bodies. Let's go outside humans, human mind interface, so to speak. You change the genes, human genes, to make it smarter, or you merge with the technology, cyborg. There's no scenario where we solve these problems, or you simply let the problems go unsolved and just say, okay, we're going to live with things as they are. That's not a very good solution, unsolved, if you have a disease and it's incurable. So that's, I think, one of the primary things driving this. And there will be some pros and cons and good aspects and bad aspects of the technology for sure. But this is part of what's driving it. The second thing is simply we have so much unused computing capacity today. Okay, is a second driver. We'll say this is one driver. This is a second driver. The computing technology, most of the time, if you have a high-end desktop, if you buy the modern desktop, your computing power is going unused. The software is not making use of that technology to drive productivity. And so there's even today, there's a lot of unused compute capacity that could be put to use to make things work better, so to speak. So your average computer, your desktop computer, probably runs at, your high-end computer probably runs at 5 to max 20%. So obviously response time is important. It's critical for human perception of processing. But the computer is largely unused. The computing power is largely unused, and then and then the second capacity, and that's also we also have increasing. We also have, that's just computing power. We also have space capacity today's that are pretty much unheard of. You can buy a 20 terabyte hard disk today, which is, you think about it, that's just crazy amount of space there. So, and it's cheap. So we have unused computer capacity, and we have space capacities, and they're cheap. So we have this unused. If we can learn how to use that, it's already exists. We don't have to get faster computers, and so to speak. And the third thing driving it is, the third reality, or the third thing driving this, is that the technologies are working. The technologies are solving problems that they haven't been able to do. So you have general purpose algos produced by OpenAI. A lot of those first come from Google. It started from Microsoft. Much of it originated at Microsoft, but much of it today has been driven by OpenAI and Google. And you have technologies that are general purpose that did things like beat people in chess. Now, chess was, you say, okay, well, chess, we'd already been beaten by computers in chess, 30 years ago. But that was different. That was a specialized program. These new programs are general purpose. So not only in chess, but Go, which is exponentially more difficult, online games, and so they're doing things that we haven't been able to do. And basically, what that means, it's all going to combine to where the value proposition for the next 20, if I see it for the next 5 to 20 years, is going to be machine learning driven value propositions. And it doesn't matter what technology field we're talking about. So, for trading, it's going to be machine learning AI based assisted trading, or some form of using that in your automated trading. Okay, but that doesn't apply to trading. This is kind of something that's driving everything. And programming, it's going to be stuff like the GitHub Copilot, machine learning based Copilot, machine learning. That looks like a machine language when you look at it in that way. Machine learning based program assistant, right? And it's just going to get better and better. You have this massive, and it's just kind of basic. You have this massive database of code that's out there in GitHub. You also have it inside the programs themselves. Now, yes, there may be legal implication, reverse engineering, but there's already a massive body of code, and all it's needing is to be put into a database and given intelligence to drive decision making. It's just a natural. It's kind of surprising it hasn't been done already. And so what does that do? What does machine learning? It's going to allow. This is going to allow programmers who have a certain level of ability. It's going to bump them up, make them more productive, and it's going to allow. One of the things I'm looking for too is there's always. I don't see this replacing computer specialists and programmers and stuff in that sense. But what it may do is if you're already an accomplished programmer in say C# and you want to program in Python, and there's normally a transition period. And actually, if you program too many languages, your performance in one can get hindered because of certain things you have to do. So I program an easy language in C#, and C# requires a semicolon at the end of a statement, and easy language doesn't. And so when I switch back and forth to those two languages, sometimes I'll make a mistake. Because there's competition there in terms of learning both of those languages, so some things are not exactly the same. Now, for the most part, having more permanent language experience will help you learn other languages and help you become proficient in them. However, at some level, they can become conflicting. The point is that just because I'm an expert in one language doesn't mean I'm an expert in another language. Now, I can become an expert very quickly, much more quickly than a non-programmer. With these machine learning-based assistants, that could be increased quite a bit because there's always certain little commands and things you look up, and it's what we might think of as an explosive problem. In that, okay, I'm going to do something simple. I know all the abstract ways of computer science and programming languages, but I have to find this specific command. I have to find a very specific command. So if I don't have a code snippet, I have to either make a cookbook or do an example to learn how that command works, or find an example, and then it may have parameters and things, and that's another explosion of information. So if I'm in programming multiple languages, I'm not going to be as productive. Now, this is one factor with these, could be negative with these types of technologies, is that what that does is it keeps there's a high degree of specialization. And that specialization keeps programming salaries high across the board because, it's very hard to find just the specific programmer that you need, so to speak, or the specific developer, software developer. With these machine learning based assistants, it's going to have a couple of implications. One, it's going to allow the developer to do things. It's going to raise the bar of what you can accomplish. So from a personal standpoint, that's a great thing, that you're able to program things that you couldn't have programmed that maybe just slightly outside your capability before. You're able to program things that you can program today and do it faster and more efficiently. And then you're going to be able to program in languages that you don't know as much about. And that could have the implication of reducing the value of specialization. Obviously, those programmers who don't, and the software engineers and developers who are not able or not utilizing this technology, the people who utilize it first will have an advantage over those who don't. But there is no turning back the clock, so to speak. So there's going to be pros and cons. There's going to be benefits and detriments with this technology. The same way in art. There is a algo, if I can think of the name of it, Wally, right? Wally, that enables you to create photorealistic artwork and artwork in any style. This Wally 2, actually. It's another, I think it's an OpenAI project. But at any rate, it allows you to create artwork just by giving a description. And the artwork is the new, at least with Wally 2, it's not available it's not available yet, but the artwork that it produces is high resolution, high quality, looks like it was created by a human. Now, how transformative this will be is basically how much, there's two sides to making art, right? There's one side is the quality component, the rendering quality component, or the final production, and then there's also the ability to iterate, refine, and to basically get what you want. And it can produce multiple samples. So if there is the ability to refine and iterate and to improve through incremental improvement to drive toward a goal, then it will be a valid way of creating art. In other words, if you'll be able to create one thing I like to think about for artwork, I did some painting, some digital painting and stuff, and I studied art for a couple of years. And one of the things I look at, there's this idea, okay, what is real art? What is not real art? Because there's so many possibilities today. There's Unreal Engine 5 today, which can render photorealistic scenes. And I've been thinking about that could be an avenue for art creation, for still art, or, you can do 3D renderings. And what really drives that is the ability to refine. It's the ability to have a vision and reach that vision. That's why and that's my take on it. That's why the old masters would take and copy so much. So what I'm thinking is that if you can have a set vision, and if you can describe it and iterate over it to reach some a good proximity to what you envision, then this is going to be what does this change, right? Well, it's going to make let's say you're producing a small newsletter, e-zine type of production where you don't have maybe it's a small publication on trading, maybe it's some sort of a tech book or comic or whatever. And if you don't have if you wouldn't have the ability to hire an artist or to work with an artist, with just a little bit of artistic skill, a little bit of artistic leaning, you could probably go in there and create illustrations for your book with just very quickly. So, another avenue you'll see with this is creating textures, right? If you're a 3D artist, let the computer create textures that you might not be able to create, or create new textures from existing textures. So the key commonality is your value proposition for almost everything interesting that you think about, because these old technologies have been around for so long. Almost any way you think about innovating or improving is going to involve Yeah. So any way you would think about innovating is probably involving some machine learning AI based component. Um, so that's how I see it. So again, thinking back on the Copilot, uh, yeah, it's pretty impressive. It's pretty even with the limitations. It may not be ready for prime time yet. Obviously, it's a preview, but this type of technology was not even in the realm of possibility. Even a few years ago potentially. So this is going to be driving everything.